Welcome back. We're going to have our second lesson from section 8.2 on absolute value inequalities. We're going to take the techniques we learned from the first lesson of section 8.2 and solving absolute value equations, and we're also going to take the work that we did from section 8.1 and merge these two skills together. So let's go ahead and dive in to see what this is going to look like. So we're going to take a look at one small problem here, 63, and then we're going to compare that with question number 65. So I have the absolute value of A is going to be less than or equal to 9. So what we're going to need to do with this question is we can split this up. So we need all the possible values of A that are going to give us a value equal to 9 or less than 9. So when we split this up now, it's going to work the following way. I can write this as A is less than or equal to 9. Okay, and I can also write this as A is greater than or equal to negative 9. So you'll notice that in addition to making the 9 negative here, we also change the direction of the inequality. And that is going to be one of the key components of this work. So it's not simply writing this as positive 9, negative 9, but here we preserve the direction of the inequality. Here we change the direction of the inequality. And you'll see that as a common occurrence here. But we have to do more than simply this. We're not going to be able to express this answers using simple set notation for this. We really need interval notation now. So set notation is not going to come in here because we're not looking at one or two specific answers, not in most cases. This is going to be something that's going to involve interval notation. So let's go ahead and put this solution to a number line. We're going to put the values of negative 9 and 9 here. Don't put 9 here and negative 9 here. That's a big mistake because we always have to go in order from least to greatest when we go left to right. For the value of 9, this is going to be less than, going to the right. And because it's less than or equal to, we put a bracket here, going this way. We also need the values that are going to be greater than or equal to negative 9. So we're going to put this here, going this way. And we notice we get the values that are in between here. So remember, all the values between negative 9 and 9 will make this true. For example, negative 1. Well, the absolute value of negative 1 is 1. And that's less than 9. So this looks like it's going to be true. So here's how we represent the solution to this absolute value inequality on a number line. How do we represent it in interval notation? Exactly as we did before. Bracket, bracket, negative 9, 9, comma. And now we have the solution to this absolute value inequality expressed in interval notation. Let's take a look at another problem, which will be number 66. This is going to be modified just a little bit. So if you're looking in your book and you're saying that this is not quite exact, you are correct. I want to make sure that I represent both types of problems that can be done here. So if I have t is greater than 1, I can split this up to say that t is greater than 1. I can also say that t is less than negative 1. So again, I'm going to take this. I have to negate this, and I have to switch the direction of the inequality. And we're going to see what this solution looks like on a number line. So if I put negative 1 here, I put 1 here. Well, let's see, for t to be less than negative 1, that means it has to be an arrow going to the left with a parenthesis here. For t greater than 1, it has to be a parenthesis going this way. So you see we have the arrows going opposite directions, unlike the first example that we showed. So what is this going to look like in interval notation? Well, this goes all the way to negative infinity. Remember, with negative infinity, we always use a bracket. This is going to go all the way to negative 1. I close a parenthesis there. Here, I'm going to write this from 1, 2, and this goes all the way to infinity. I close it off there. And because this has to be as a common solution, we are going to take the union of these two things. So I'm going to put the union symbol here. And here will be the answer to the absolute value inequality we've just solved, expressed in interval notation. So here it is in interval notation. Here it is on the number line. Here's the algebraic representation we obtained through our work, which for this is very simple. So we're going to take a look at more complicated problems to see what happens with these and see what we have to do to solve them and properly express their solution. So let's go ahead to some more complicated questions, but not terribly bad to start. We'll go to 67, and we have first x minus 1, the absolute value of that, being less than 4. So when we have something like this, we're going to split this up into two parts. We have the absolute value alone on one side, and we have this here. So we'll write x minus 1 is less than 4. On the other side, we're going to write x minus 1 is greater than negative 4. And we're going to see what numbers make this true. So by adding 1 to both sides, we'll have x is less than 5. By adding 1 to both sides, we have x is greater than negative 3. So we have x is less than 5 and x is greater than negative 3. Let's go ahead and put these on a number line, and let's see what kind of graph they're going to generate. So if you have x is greater than negative 3, it looks like it's going to go this way. If we have x is less than 5, it's going to go this way. So it looks like we're looking at some values here between negative 3 and 5. 0 should be 1. Let's see if that works. Well, 0 minus 1 is going to be negative 1. The absolute value of negative 1 is 1, and 1 is less than 4. So looks like we're in the right ballpark here. So how do we express this now in interval notation? Just like we've done before, so no difference here. Parenthesis, parenthesis, negative 3, 5, and now we've expressed the answer to that absolute value inequality in interval notation. So let's go ahead and take a look at another such problem here. I'm going to take a look at 75. So we've got the absolute value of 3a minus 4 plus 2 is going to be greater than or equal to 8. So like the absolute value equations that we were solving, we have to get the absolute value alone first before we can split this up into two parts. So we're going to go ahead and subtract 2 from both sides. So this will give you 3a minus 4, or the absolute value of 3a minus 4, is greater than or equal to negative, not negative 4, I'm thinking division. This will be positive 6. So 8 minus 2 will be positive 6. My apologies for that mistake. Now I'll go ahead and I'm going to split this up. It's going to be 3a minus 4 will be greater than or equal to 6. Then 3a minus 4 is going to be, switching it around, less than or equal to negative 6. So remember, I switched the inequality and I switched the sign. So going forward, we add 4 to both sides. So we have 3a is greater than or equal to 10. And then if I divide by 3, we have a is greater than or equal to 10 over 3. On this side, if we add 4 to both sides, we have 3a is less than or equal to negative 2. And then if we divide by 3, we have a is equal to negative 2 over 3. So remember, we don't express this as a set. We need to put this on a number line, and let's see what happens with our solution. So negative 2 over 3 is going to go here. 10 over 3 is going to go here. And this should not be equal. This should be less than or equal. So we have less than or equal negative 2 over 3. A bracket is going to be going this way. For a greater than or equal to 10 over 3, it's going to be a bracket going this way. So it looks like it's heading in two different directions again. So like the problem we just showed when we were looking at question 66, this is going all the way to negative infinity. So this is going to go from negative infinity to negative 2 over 3. That's the first part. here, this is going to go from 10 over 3 to where? Positive infinity. And because we're looking at all the solutions, we need to join these two together to make a union. So it's, oops, not a real U, just like a U shape without the stem at the end, to express this final answer in interval notation. So here's what the answer looks like on a number line. Here's what the answer looks like in interval notation. Here's what the answer looks like algebraically that we first obtained. So as you see here, the work is not a lot different than what we did in the other questions. So let's just take a look at one aspect of this work from algebraic perspective to kind of show you a trick that often happens. So suppose I have something like this. Absolute value of 3x minus 1. And I want to know when it is greater than negative 5. So this is just an example, nothing from the book in particular. Well, here's the thing. An absolute value is always going to be 0 or greater. It will always be greater than negative 5. If you are given an example like this, you may simply say on a number line, without putting any numbers down, that the graph of this goes all the way from infinity to negative infinity. Or you may just express this in interval notation as negative infinity to infinity. No matter what you put in there, the value of the absolute value is going to be 0 or greater, which is always going to be greater than negative 5. So the answer to this is going to be negative infinity to infinity. On the other hand, you may see a question that looks like this. 2x plus 3, when is that ever less than or equal to negative 1? Well, remember, this has to be 0, at least. It can be greater than 0, but it can never be less than 0. So it's never going to be less than negative 1. It's never going to be even equal to negative 1. So for this one, we can write the answer to this as the null set. There is no answer to this whatsoever. You may also write this as no solution. So when you see a negative on this side of an absolute value inequality, you have to be aware that the possibility exists that there may be no solution. Now, that doesn't always mean that there is no solution, but you also always have to be ready for that possibility. Let's take a look at an example of one where you may think that there may be no solution, but it turns out not to be the case. Let's take a look at problem number 89. 25 minus 2 times the absolute value of a plus 3 is greater than 19. So at first this looks pretty harmless, but as we subtract 25 from both sides to try to get the absolute value by itself, we'll get negative 2 times the absolute value of a plus 3 is greater than negative 6. So we see the negative over here, and we realize, maybe I can say no solution. However, we do have to do some work to get the absolute value by itself. If we still have a negative over here when the absolute value is by itself, then we can say no solution. However, when we divide both sides by negative 2, we're going to get the absolute value of a plus 3 being greater than positive 3. So once it is in this form, we see we have something that is reasonable that we can solve now. And we can split it up into two parts. A plus 3 is being greater than 3, then a plus 3 is being less than negative 3. And now it's a fairly simple equation to solve. By subtracting 3, we have a is greater than 0. And by subtracting 3, I have a is less than negative 6. So now I have this solution and this solution, and we're going to put these on a number line now. And we have negative 6, we have 0, please be sure the negative number has to go here, 0 have to go to the right. You don't put 0 here and negative 6 here. Don't do it. For negative 6, it's going to be less than, so it's going to go this way. For a greater than 0, this is going to work its way to the right. And we see we're going in opposite directions again. So this is the solution to this on our number line. In interval notation, this goes all the way to negative infinity, to negative 6, but without getting to negative 6. This goes from 0 to infinity, and it's going to be the union of the two. So now we have the answer to this big equation now expressed here on a number line and in interval notation. All the techniques we've learned in section 8.2, whether you're solving equations or inequalities, all the techniques where you have to get the absolute value by itself before splitting this up, all apply. The one thing that you want to be careful of is when you have a negative on the right side and only the absolute value on the left, then you've got to be careful about what type of solutions you're going to get. You also have to consider, will the negative resolve itself as I do more algebraic work and get the absolute value by itself? I hope this was helpful. Please bring your questions to class, and I will see you then.